Hello, this is Jeong from AhnLab. Today, under the topic Next Generation SOC, starting with ASM perfected by AI, I'd like to take some time to discuss with you how we currently provide security monitoring and how we should approach monitoring in the age of AI. We use ChatGPT and generative AI a lot in our work these days, right? When I asked for a simple example using code, it showed me various examples and provided the output like this. But in this field, it's not just about using it simply like this. If a developer enters their desired request in natural language, the AI can now understand it and provide highly sophisticated code. That's the level we've reached. Attackers are also using these powerful AI capabilities to carry out attacks. With generative AI, I used the year-end tax settlement as an example and asked it to create a convincing phishing email, just like this. It created a very convincing phishing email. In fact, there have been quite a few reports that phishing emails generated by AI have a much higher success rate than those written by humans. Now, let's take a brief look at how our security monitoring service is currently operating and where it is headed in this rapidly changing world shaped by AI. Even as we speak, a huge number of attacks are probably targeting your infrastructure. Most of those attacks are likely being blocked. Unfortunately, some of you may have experienced cases where an attack succeeded and led to a security breach. The screen you see here shows a situation where a web service has suffered a security breach. The person in charge has noticed it and is contacting the monitoring center. At the monitoring center, they reviewed and analyzed the events from the security solutions in place, but there wasn't enough evidence, so the response was inadequate and a security incident occurred. When you look at situations like this, do you think the attack just happened all at once? Attacks don't happen in a single step. Attackers scan for vulnerabilities, upload malicious files, and try various other methods. All these actions leave traces and generate a lot of information. If we could collect all this data and quickly analyze it in a comprehensive way, we could expect that incidents like this wouldn't happen. So if we know all these good practices, why can't we actually do them all? Among the many reasons, there are a few important limitations. The first is that our current monitoring system relies too heavily on human experts. And usually, you build your security using security solutions, right? But the problem is, we can't look at these security solutions in a comprehensive way. At least in monitoring, we analyze and respond to events generated by each solution individually. There's also a clear limitation in that we can't handle all the massive number of events that occur. Even among known threats, we end up selecting and only dealing with the most important attacks. That's why, as the amount of information that needs to be analyzed increases, the response speed slows down, and as it slows down, the probability of a critical incident occurring keeps going up. Attacks are constantly happening, so to respond to them, we need to address and overcome these limitations we've just discussed. So, recognizing these limitations and realities, we are preparing a new service called AI SOC based on our own AI platform. AI is already out in the world as a powerful tool that can be used by both attackers and defenders. It is being repeatedly emphasized that with the traditional security model, we simply cannot respond to these increasingly sophisticated attackers, and that a redesign is necessary. Therefore, to counter these advanced threats, we are shifting to an AI-based defense system. Of course, we still need to block known attacks based on existing pattern-based methods. We also need to effectively defend against unknown attacks that we are not familiar with, using behavior-based analysis and anomaly detection. Attackers will continue to launch automated attacks based on AI. To respond to these automated attack threats, it's most important for us to build an AI-based automated defense system that minimizes the time required for detection, analysis, and response. That's why we keep talking about AI. AI shouldn't just be used as a simple tool. Everyone is emphasizing that we need to move toward integrating AI throughout products and platforms, embedding it so that everything can be connected. Before we move on to AI, let me briefly go over our current security monitoring system. Our monitoring system is largely composed of prevention, detection, analysis, and response. First, if we look at the prevention side, we prepare for threats by monitoring threat intelligence and new vulnerabilities. As we monitor, we sometimes come across confirmed attacks. For these kinds of attacks, we take preemptive blocking measures so that, if an attack occurs, it can't get through. We also share reports on the analyzed attack details with you and carry out preventive activities to ensure we don't fall victim to the same attacks in the future. Not only that, from a response perspective, we automate processes to ensure our response is quick and error-free. We're putting a lot of effort into this. We're also continuously working to expand the scope of this automation. We build up our defenses first by implementing a variety of security solutions across different areas. For attacks detected at these defensive lines, and for events confirmed to be attacks through our analysis, we respond appropriately. Nevertheless, if a security breach does occur, we analyze the incident to identify its cause and areas for improvement, and we continuously work to determine what needs to be enhanced in the customer's environment and its security setup. With that in mind, we've been considering what additional elements will be necessary for the future SOC that we aim to build within our current security and payment framework. First, I think we need to expand the scope of detection. We also need to establish a system that can comprehensively assess and correlate various types of information, such as network and endpoint data, as well as behavioral analysis and activity information. Through this, we need to build a system that can proactively detect and respond to unknown threats in the gray area, such as abnormal behaviors or unusual signs, which I briefly mentioned earlier in the prevention section. Also, if we have a deep understanding of our customers' environments, we can provide truly specialized services tailored to their needs. If we can obtain such information about our customers' environments, we could train AI with that data and provide highly customized, specialized services for our clients. In order for us to move forward with new services, it's not about throwing away everything from the past and starting over, but rather making a leap to a new system based on our current monitoring framework. To make this leap, the technology and experience we already have are extremely important. At AhnLab, we are accumulating such technologies and experiences step by step, and the first of these is we provide services in this area with our products such as DDoS protection, IPS, and firewalls, which are perimeter security solutions that block and defend against known, rule-based attacks on networks and the cloud. The second stage involves moving down to the endpoint. At the endpoint level, we monitor elements such as files, processes, and events, and when an actual threat occurs, we provide EDR-based analysis and an MDR service where our experts directly manage and respond to these threats. The third stage involves collecting events from the different areas we mentioned earlier, network and endpoint. linking them together, and providing an XDR-based service that makes it as easy as possible to immediately understand the context and flow of these attacks. As previously reported by Manager Sang-Ok Chu, our experts also provide the MXDR service in this area. We believe that if we build highly intelligent, AI-based security on top of this robust security framework, we can achieve a truly complete and comprehensive defense system. If we establish an AI-based automated analysis and response system, many of the roles that currently rely on analysts can be handled by AI. Existing experts can then focus on truly important tasks. They will be able to focus on important tasks, and we expect that AI will be able to respond faster and more accurately than humans. Earlier, I mentioned our customer-tailored services. So, how exactly are we going to do this? These are some of the representative services in our consulting area. Among these, in the areas of ASM, task simulation, and vulnerability diagnosis, we plan to collect customer environment information, train AI with this data, and provide customized, client-specific services when an attack occurs. Now, let me briefly explain the procedure of our remote monitoring service. Basically, events detected by network security solutions and endpoint security solutions are collected at the monitoring center. The gathered information is then analyzed by our monitoring analysts to determine whether it is an actual attack. And if it is identified as an attack, we have a system in place to respond appropriately. This is the general framework. When we respond in this way and an attack occurs, we send a response report to the customer, explaining that such an attack happened and how we responded to it. This report includes details about what kind of attack occurred, what the attack was, and what the attacker looked like. It contains comprehensive information about how we responded to the incident. As you can see from the report, it contains event analysis for each individual solution and the corresponding responses to those events. Ultimately, responses are only possible within the scope of what can be analyzed. Since the overall process relies heavily on the monitoring staff who analyze and respond, it takes time, and even that time is not always consistent. There are some things that change when we transition to an AI-based SOC. We will continue to receive events from the existing security solutions as before. In addition, we will also collect various behavioral information that we consider important. By combining even reputation information, we believe that instead of analyzing and responding to these pieces of information individually, we need to analyze them in an integrated manner. When we do this, the reports we can provide look quite different from the ones we saw earlier. The focus of these reports is not just a simple analysis of events generated by a specific solution, but rather they include the overall context of the attack. As the basis for understanding this context, we refer to events detected by various security devices and reputation information, so the report will show the overall flow of the attack. Of course, the response will not rely on a single solution, but will involve configuring the appropriate security solutions, and this process will be carried out very quickly based on AI automation. However, there's one thing we need to clarify here. AI is not going to do everything. AI suggests the best possible methods, but the process is completed only after review by skilled experts. Now, let's take a look at a comparison between current security reports and the kind of reports we aim to produce. This is a summary of what I explained earlier. In the previous system, where analysis and response were handled individually, we will take in various security solutions and information in a comprehensive manner summarize them, and present the results as a combined analysis. The summary of this analysis will be visually represented so that you can see the overall flow of the attack. And again, the key is to automate even this complex response process using AI, so it can be done quickly. Up until now, we've been talking about detection and response, right? But actually, in addition to threat response, a significant part of our work involves handling requests from you, like tickets, emails, and so on, and providing support for those. We fully understand what kinds of inconveniences our customers experience in these areas as well. So let me briefly go over the current process and explain how it will change. Currently, our technical support system can generally be divided into three main categories. You can submit a ticket through our monitoring portal or make requests via email or phone, but the time it takes for these requests to be received by the monitoring staff, processed, and responded to can be quite inconsistent. Sometimes, when you need to extract a specific log, the staff might be busy, or there could be a sudden incident due to another issue or for various other reasons. So it's inevitable that there will be some inconveniences. To address these issues, we're planning to use AI to make simple, routine tasks more convenient for you first. As you can see, there are things like status analysis, execution requests, and Q&A. We're first implementing system features that can handle simple inquiries about detected records or generate certain statistics, so that both customers can use these functions conveniently and staff can focus on truly important, specialized areas. Through this, we aim to improve and ensure the speed and quality of our monitoring services. Now, using the AI SOC I've discussed so far, let's briefly look at how it would respond by applying a scenario where an actual attack occurs. In this scenario, an attacker exploits a web vulnerability to transfer a malicious file, takes control of the internal system, and ultimately leaks the targeted internal information. I'll briefly explain this by dividing the process into three stages: establishing a foothold, taking control, and exfiltration. First, in the foothold establishment stage, since the web is being used, the attacker will run scans for web vulnerabilities. As you might expect, during this process, many of these attack patterns will be detected by the web firewall on the network. However, scans for web vulnerabilities like these are pretty common and routine, so they're not considered highly dangerous. But if we have information about external exposure vulnerabilities for these services through ASM, and a scan attack matches the vulnerability information we've gathered here, then this isn't just a routine scan. It could become a very dangerous attack. This is a simple example of how you can immediately increase the risk score by correlating information. When malicious code is uploaded and a malicious file is created, you can also correlate detection information from the network device where the malicious file is uploaded and from the endpoint, allowing you to see the flow of the attack together. When the malicious file is executed and actually communicates with the command and control server prepared by the external attacker. Also, during the process of receiving the malicious file, you can use threat information from network devices at the boundary and from endpoint EDR devices to see that communication was made to the attacker's command and control server, and that reputation check showed communication with such an IP. This is a case where you can clearly understand the sequence of actions that took place. In this situation, the AI SOC would be able to represent the entire context from the initial scan to the execution of the file. It would combine all elements such as time, reputation, and detection information. At this stage, the best course of action should already be presented so that the staff can immediately review and apply it with the process completed. This is what we mean by speed. Next is the reconnaissance stage. In the reconnaissance stage, unlike the previous attack methods, there are characteristics of lateral movement attacks within the internal network. The web server has been compromised, and from there, scans are run to find the actual target for the attack. There are certain characteristics when running these scans, right? You'll see traffic increasing, but without a corresponding increase in sessions. And you can correlate this with network information, endpoint data, and threat intelligence, TI, information. Once the actual target is found, they'll try to upload a malicious file to the destination and make efforts to execute that malicious file. This is the part about file movement. In this entire process, if you've already learned the internal traffic patterns of your environment, the effectiveness can be maximized even further. On the actual destination server, if a malicious file somehow gets executed, causing processes to run and malicious activities to occur, AhnLab EDR is very good at detecting these kinds of behaviors. Through this kind of information, even in a situation where the system has been compromised and there is almost no internal or external communication, such as in a lateral movement attack within the network, we expect that by using network data, file movement, file reputation, and various other information, it will be possible to sufficiently analyze and track the flow and connections of the attack. Finally, we come to the data exfiltration stage. The attacker has found all the information they want from the AD server, and to leak it outside, they will compress the files. Since the compressed files can't be sent out directly, they'll upload them to an intermediate web server as a staging point. Even during this process, activities related to file compression, the traffic generated by the transfer of large volumes of files, and various logs about file creation on the staging server all continue to occur. Assuming they've succeeded in moving the files, when transferring the large compressed files from the web server to the C2 server, the spike in traffic becomes very noticeable. These files will also have to pass through all the network devices at the gateway. Through this kind of clear information, we expect that we'll be able to see the entire flow by correlating all the data. Finally, after the attacker has taken everything, they might try to run ransomware to destroy everything and hold it hostage in order to demand money. There are several characteristics of ransomware when it runs. For example, when a large number of files are suddenly modified or changed, our EDR can detect even these kinds of activities, block certain processes from running, and take real-time actions such as isolating ransomware files. As you saw earlier, during the attack process, files are compressed, moved, and sent externally. While each of these actions might not seem significant on their own, when combined, they allow us to see the overall flow of the attack. This is what we consider to be a part of the correlation analysis that we aim to achieve. The AI SOC we are preparing will collect and correlate various pieces of information from different environments, even if those pieces of information may have different meanings. We will continuously train the AI with these correlated and analyzed pieces of information. Then, the AI will keep evolving. Also, by leveraging AI-based automation, we can quickly and efficiently establish a response system, and through this, we can confidently promise to provide our customers with a convenient and advanced SOC. We keep talking about AI and AA, but we are not relying solely on AI. Instead, we will utilize AI based on the expertise of our analysts. Our goal is to make the best use of AI to analyze information thoroughly and respond as quickly as possible. Now, I believe that everything will change depending on how we use AI. AhnLab will take the lead and strive to deliver the kind of security monitoring you have been hoping for and perhaps felt was lacking. That concludes my presentation.